Galileo in 1620 hypothesized that object in free fall behaves d proportional to t square. What does that mean? That means when you drop an object, it is in free fall because you dropped it in space and you allow it to fall under the influence of gravity. This is why we call it free fall. And body object in free fall displays proportional to square of time, and from that he deduce d is equal to half a t squared. Today I will show you another important kinematics equation and I'll derive it. This one has to do with projectile motion. Now you see, the Galileo also said that he was the first person to realize that projectile motion is the parabola. What is projectile motion? Yesterday I showed you what is the free fall. Free fall simply means you're letting an object fall, you're letting an object to go, and it falls under the influence of gravity. Then what is projectile motion? Projectile motion, when you throw something in the air, it creates parabola. So according to Galileo, was the first person to realize that projectile motion is a parabola. And today I'm going to first derive kinematics equation that was first derived by Galileo about 1620, and we're going to solve a problem, a parabolic problem, a projectile motion problem using this equation. So let's dive in. Cross multiply, we see x minus x naught is equal to the average velocity times t. Now don't forget what is average velocity is. Average velocity is v plus v naught over 2. So we're simply going to replace this by v plus v naught over 2, and then we're going to write t over here. Now the t should be replaced by, let's see what is t. Acceleration is v minus v naught over t. So then t should be v minus v naught over acceleration. So I'm going to replace t by v minus v naught over acceleration. So v plus v naught over t. Now I'm going to replace this t by this t. And what is this t? This t is v minus v naught over acceleration. Let's replace this t by v minus v naught over acceleration. Now let's use distributive property to see to multiply them. So v times v minus v times v naught, and then plus v naught times v and minus v naught square over 2a. So we can cancel something. We can cancel v naught and v naught v. So x minus x naught is equal to v square minus v naught square over 2a. So we can cross multiply both sides. V minus v naught square is 2ax minus x naught. Okay. Now we can simply write v square minus v naught square is equal to 2a. This is the change of x, change of position. So change of position means delta x. This is change of position. Don't forget that. Now I'm going to rewrite this equation over here so that we can simplify. V square minus v naught square is equal to 2a change of position. Okay. Now we're going to write v square is equal to v naught square plus 2a delta x. As you see that v naught and v initial, they are the same thing. So v naught and v initial, they are the same thing. Sometimes we call it v naught, sometimes we call it v initial. Some book call it v initial and some book call it v naught. You can, most of the time v naught or v initial is 0. Okay. So then we can call this one, instead of v we can call it V final square is equal to V initial square plus 2a. Instead of delta x, we can call it delta d, since the SI unit for x is meter and SI unit for d is also meter. Now this you can find in the reference table, page number 6, equation number 5. But there is a mistake in the reference table. They do not have this delta sign. So I figured that out. I discovered it when I was deriving it. So you're going to use this to solve a projectile problem. Okay, let's create a problem. Let's say Barry throw a ball. So instead of show the parabolic, I want to throw a ball and I show you what's going to happen with the ball. So let's create a ball and I'm going to throw the ball and I'm going to catch it on the other hand. And I catch it here. So I have to apply some initial velocity to launch it. If I do not apply initial velocity, I cannot launch it 15 meters per second. If I don't apply initial velocity, then it won't leave my hand. So now let's draw that. So this is called position A, my one hand. I apply some velocity and it creates a projectile motion, position B. Alright? Okay. And I apply some velocity, Vi is equal to 15 meters per second. Now this is called projectile motion. Why it is called projectile motion? Because it's parabolic. According to Galileo, projectile motion creates parabola, and this is a history over here, piece of history over here, kind of discovered by Galileo 1620, about 1620. All right, now a few things you have to understand. Okay, so velocity is a vector quantity. Velocity has two components. Velocity has two components, Vx and Vy. Vx is constant. Vx is constant, Vx never changes, because acceleration due to gravity do not affect the Vx. Vy changes. The Vx, so I'm going to erase these and quickly I'm going to draw the both component of velocity, although you do not need to know the both component of the velocity. Not now. When we do 2D kinematics, you need to know that. But those of you who want to understand it in advance, this is for you. So velocity has two components. This is Vx. Let's consider how many points we can draw from here to here. Millions of points. But let's draw only 7 points. Point number 1, point number 2, point number 3, point number 4, point number 5. Let's draw only 5 points. So this is the x component of the velocity. This is the x component of the velocity. Now I'm going to draw the y component of the velocity. The y component of the velocity decreases. Y component of the velocity is 0. Vy is 0 here on the top. I'm going to show you again why Vy is 0. When I throw the ball in the air, it creates a projectile motion and it returns to my hand. It will never return my hand if the velocity at the maximum point is not 0. So velocity at the top of the parabola is 0. Velocity at the maximum height of the parabola is 0. Let's observe it again. So the ball created a parabola. At the maximum height of the parabola, the velocity is 0. The ball had to stop. The ball had to stop in order to change the direction. How the ball is changing the direction? Ball is going up, stop for a fraction of a second, and then the ball return to the hand. So in order for the ball to return to my hand, ball has to changes the direction. So when ball changes the direction, ball has to stop. Ball has to stop for a fraction of a second, and the velocity of the y component is 0. So make sure you understand that part. So velocity of the y component is 0. But now we're going to go back to one dimension. This is something you don't need to know now, because when we do two-dimensional kinetics, then you need to know that. So now only you need to know Now only you need to know the velocity y direction right now. But since I started it, let me finish it. So this would be Vy and this would be Vy. So why is that? Because the initial velocity, the velocity is this way, initial velocity, and velocity component fight with the acceleration due to gravity component. So acceleration due to gravity, today you learned that acceleration due to gravity is the downward arrow. Now you see why this velocity decreases, because it has to fight with the downward arrow of the acceleration due to gravity. So when they fight each other, the velocity, the initial velocity decreases and goes to 0. And then the ball is stopped for a second and the ball return back to the other hand, left hand. So when ball return, then the acceleration due to gravity always down, no matter what. Here, the acceleration due to gravity is always down. Don't forget that. And the other one, the velocity in this case is down. So if initial velocity is 15 meters per second, the final velocity is negative 15 meters per second. Okay, now what we need to know is how high the ball go. How high the ball go. So if I throw the ball from one hand and it's arrived in the other hand, how high did the ball go? If my initial velocity is 15 meters per second. So I'm going to use this formula to find it out. So let's use this formula. So BF, I'm going to let the VF 0. I'm going to call this one VF. I'm going to draw this one again, but this one is going to be a little clean. Here, I know that V initial is 15. Here, I'm going to call it the maximum height. At maximum height, velocity has to be, y component of the velocity has to be 0. Because I said that. You throw the ball at the maximum height, y component of the velocity has to be 0. Otherwise, the ball won't change the direction and ball won't return to the other hand. So now, I'm going to rewrite this formula. This way. Y component, y component, y component, y component. Because I'm going to make this formula a free fall formula. Why projectile motion is a free fall? Well, projectile motion is projectile motion is when you throw something in the air, you're going to throw it in the space and allow it to move under the influence of gravity. So if I throw it in the air, I have to allow it to move under the influence of gravity. That makes it projectile. If you don't allow it to move under the influence of gravity, then it's not a projectile. Okay, now let's solve the problem. So we made it a free fall equation. So now let's move it here. BF y squared is equal to VI y squared plus 2AD. Okay, now BF, I said that we're going to let this one is 0, is equal to VI is 15. So 15 meters per second squared plus 2. Acceleration due to gravity is 9.8 meters per second squared. And then the D is the one we have to find. Okay? So let's see what is it. This is, so D is negative 2 times 11.5 meters. So the height of this ball, the maximum height from here, this height is 11.5 meters. All right, thank you.